Find an antiderivative or integral of the following functions by the method of inspection sin 2x. And we know that derivative of, that is d by dx of cos 2x is equal to minus sin 2x into derivative of 2x will be 2 by using chain rule. That is derivative of cos 2x is equal to minus 2 times of sin 2x, or we can also write, bringing this minus to the other side, minus 1 by 2 d by dx of cos 2x is equal to sin 2x, or this can also be written d by dx of minus 1 by 2 cos 2x is equal to sin 2x. So which implies that derivative of a function is sin 2x. So we can say that antiderivative of sin 2x is, we can write antiderivative of sin 2x is minus 1 by 2 cos 2x. So minus 1 by 2 cos 2x is the answer. Thank you. Find an antiderivative or integral of the following functions by the method of inspection cos 3x. And we know that derivative d by dx of sin 3x derivative will be cos 3x into differentiation of 3x is 3, or we can write d by dx of sin 3x is equal to 3 times cos 3x, or 1 by 3 times of d by dx of sin 3x is equal to cos 3x, or d by dx of 1 by 3 times sin 3x is equal to cos 3x. So which means differentiation of a function g of x is equal to f of x, which means that integral of f of x dx is equal to g of x plus c. So we can say by antiderivative, we can say that antiderivative of cos 3x is 1 by 3 sin 3x. Okay. Find an antiderivative or integral of the following functions by the method of inspection e to the power 2x. And we know that differentiation of e to the power 2x is equal to e power 2x into differentiation of 2x is 2, or we can write 1 by 2 d by dx of e power 2x is equal to e power 2x, or this can also be written d by dx of 1 by 2 times of e power 2x is equal to e power 2x. So differentiation of a function, differentiation of 1 by 2 e power 2x is equal to e power 2x. So we can write antiderivative of the right side function e power 2x can be taken as the left side differential function, that is 1 by 2 times of e power 2x. So we can write antiderivative is 1 by 2 e power 2x is the answer. Okay, thank you. Find an antiderivative or integral of the following function by the method of inspection ax plus b whole square. Let's take derivative, or we know that derivative d by dx of ax plus b whole power 3, we can write 3 times of ax plus b whole square into differentiation d by dx of ax plus b by using the chain rule method. So we can write d by dx of ax plus b whole power 3 is equal to 3 times of ax plus b whole square into differentiation of ax plus b is a. Or we can write 1 by 3a times d by dx of ax plus b whole power 3 is equal to ax plus b whole square. Or this can also be written d by dx of 1 by 3a into ax plus b whole power 3 is equal to ax plus b whole square. So differentiation of a function is equal to x plus b whole square, and hence we can say that antiderivative of ax plus b whole square can be taken as 1 upon 3a into ax plus b whole power 3. Okay. Find an antiderivative or integral of the following functions by the method of inspection. So here it's given sin 2x minus 4 times of e power 3x. Let us split into two parts. Let's find by inspection, by the method of inspection, we know differentiation of cos 2x is equal to minus 2 sin 2x, or we can write minus 1 by 2 d by dx of cos 2x is equal to sin 2x, or we can write d by dx of minus 1 by 2 cos 2x is equal to sin 2x. So from here we can say that antiderivative of sin 2x is minus 1 by 2 cos 2x. We can write antiderivative of sin 2x is minus 1 by 2 cos 2x. Let's find the other function. Let's find the other function 4 e power 3x, and we know that differentiation d by dx of e power 3x is equal to e power 3x into 3, or we can write d by dx of e power 3x is equal to 3 by 4 into 4 times of e power 3x just by multiplying and dividing with 4, so that 4 by 3 times of d by dx of e power 3x is equal to 4 into e power 3x, and this can also be written d by dx of 4 by 3 e power 3x is equal to 4 into e to the power of 3x, which means that antiderivative of 4 e power 3x is 4 by 3 e power 3x. So from this both we can just consider, that antiderivative of the given function is minus 1 by 2. We can write minus 1 by 2 cos 2x minus 4 by 3 e to the power 3x. So minus 1 by 2 cos 2x minus 4 by 3 power 3x is the answer. Okay, thank you. Find the following integrals. Integral 4 e to the power 3x plus 1 dx. And we know that integral f of x plus g of x of dx is equal to integral f of x dx and integral g of x dx. So we can separate here integral 4 times e to the power of 3x dx plus integral 1 times dx. And also we have the property integral k times, where k is a constant, k times f of x dx is equal to k into integral f of x dx. So we can write here 4 times integral e to the power 3x dx plus integration of 1 dx. And next we also have integral e to the power of ax dx is equal to e to the power of ax upon a. Even without integration formulas, by inspection method we have simplified this model in the earlier problems. So we can conclude here e to the power of ax dx is equal to e power x upon a plus c. So here I can write 4 times of e to the power of 3x upon 3 plus some constant c1. And now integration of 1 dx, we can write it as integration of x to the power of 0 dx, that is x to the power of 0 plus 1 divided by 0 plus 1 plus some constant, by using integration of x power n dx is equal to x power n plus 1 upon n plus 1 plus c. So here we can say that this is x plus c. So another, we can write here integration of 1 dx is nothing but x plus another constant c2, where c1 is constant and c2 is constant. I can write here 4 by 3 times of e power 3x plus x plus c1 plus c2 will consider as one integral constant c. So the answer for 4 e power 3x plus 1 dx is 4 by 3 e power 3x plus x plus c is the answer. Okay. Find the integral x square times 1 minus 1 upon x square dx. So we can simplify here integral x square minus x square into 1 upon x square dx, which is equal to integration of x square minus 1 dx. Here x square and x square gets cancelled, so it is 1 dx. And by using the properties of integrals, so we can write integral f of x plus g of x dx is equal to integral f of x dx plus integral g of x dx. So here we can write integration of x square dx minus integration of 1 dx. So by using the formula again, integration of x power n dx is equal to x power n plus 1 upon n plus 1 plus some constant. So we can write here x to the power of 2 plus 1, that is 3, divided by 3 plus some constant c1 minus integration of 1 dx. So here we can write integration of 1 dx is nothing but x plus some constant. So let me write here integration of 1 dx is x plus some constant c2. So which is equal to x power 3 divided by 3 minus x plus c1 minus c2. So c1 and c2 are some constants. I can write here x power 3 by 3 minus x plus some constant c. Okay. So the answer for x square of 1 minus 1 by x square is x power 3 by 3 minus x is the answer. Okay, thank you. Find the following integrals. So integral ax square plus bx plus c dx. From the properties we can write integral of ax square dx plus integral of bx dx plus integral of c dx. So here we can also use the property. So here the properties we used f of x plus g of x, the whole dx is equal to integral f of x dx plus integral g of x dx. This is one property. And again we may also use the property integration of k into f of x dx is equal to, we can bring this constant k into integral f of x dx, we can write and also integration of some constant dx is equal to k into integral of 1 dx, that is kx plus c we can write. Okay, let us use them here. So integration, here we can write integration a into x square dx plus b into integral of x dx plus c into integral 1 dx. And also we have integration of x power n dx is equal to x to the power of n plus 1 upon n plus 1 plus c. So here I can write a into x to the power of 2 plus 1 upon 2 plus 1 plus some constant c1, and here b times of integration of x we can write it as x to the power of 1 plus 1 divided by 1 plus 1 plus some constant c2 plus c times of integration of 1 dx is nothing but x plus some constant c3. So here we can simplify a into x to the power of 3 divided by 3 plus c1 plus b into x to the power of 2 divided by 2 plus b into c2, and here c times of x plus c times of c3, and here I can just round off some constants here, c1 and bc2 and cc3, all the three are constants, we can add them and we can write it as only one single constant, take it as some d or something. So here we can give the answer a into x power 3 divided by 3 plus b into x square by 2 plus cx plus some d, where d is equal to c1 plus bc2 plus cc3. It's a constant. So the answer is ax power 3 by 3 plus bx square by 2 plus cx plus d. Okay. Find the following integrals. So here integral 2x square plus e power x dx. So we can write it as integral of 2x square dx plus integral of e power x dx. So we can also write it as 2 into integral of x square dx plus integral of e power x dx. And we have the property integration of x power n dx is equal to x to the power of n plus 1 upon n plus 1 plus c, and integration of e power x dx is equal to e power x plus c. So here I can write 2 times of integration of x square is x to the power of 2 plus 1, that is 3 divided by 3 plus some constant c1, and here integration of e power x is e power x plus some constant say c2, and now 2 by 3 times of x power 3 plus 2 times of c1 plus e power x plus c2. So here c1, 2 times of c1 plus c2 is a constant. Let us consider c is equal to 2 times of c1 plus c2 is another constant, and hence we can give the answer as 2 by 3 x power 3 plus e power x plus some constant, integral constant c. This is the answer. Okay. Find the following integrals. Integral root x minus 1 upon root x whole square by using a minus b whole square formula. We can write a square minus 2ab plus b square. So here I can write root x whole square minus 2 into root x into 1 upon root x plus 1 upon root x whole square dx. So root x whole square is nothing but x. Root x the whole square is x we can write. So we can simplify here, this is x minus 2 into, here in root x and this root x gets cancelled. So 2 into 1, and again next plus 1 by root x whole square is 1 upon x dx. So this can also be written x dx minus integration of 2 dx plus integration of 1 upon x, that is x to the power of minus 1 dx. We know that integral x power n dx is equal to x to the power of n plus 1 upon n plus 1 plus c. So here we can write x to the power of 1 plus 1, that is 2 divided by 2, plus some constant c1, minus again 2 times of integral dx. So integration of dx is equal to, that is integration of 1 dx is equal to x. So I can take 2 outside, 2 into, and I can write this is 2 times of x plus some constant say c2, and again integration of x power minus 1. So integration of 1 upon x will be log x. So let me write the same here. Instead of writing x power minus 1, let me write 1 upon x. And we know that integration of 1 upon x dx is equal to log x to the base e plus some constant. So I can write here log x to the base e plus some constant say c3. So which is equal to, by taking c1 minus c2 plus c3 is another constant, you can give the answer x square by 2 minus 2x plus log x plus some constant c, where the c is equal to c1 minus c2 plus c3. It's a constant, integral constant. So this is the answer. Okay, thank you. Find the following integral. Integral x power 3 plus 5x square minus 4 upon x square dx. We can simplify this as x power 3 upon x square plus 5 x square upon x square minus 4 upon x square dx. We can write x power 3 upon x square is x, 5x square upon x square is 5, minus 4 times of x power 1 upon x power 2, we can write x to the power minus 2 the whole dx. Or we can simplify x dx plus integral of 5 dx minus integral of 4 x to the power minus 2 dx. And we know that integral x power n dx is equal to x to the power of n plus 1 upon n plus 1 plus some integral constant c, and also integral k into f of x dx is equal to, we can add k times of integral f of x dx, and also integration of 1 dx is equal to x plus some constant integral. So here we can apply it. Integration of x power 1 dx is x to the power of 1 plus 1 2 divided by 2 plus some constant c1 plus here integral, that is 5 times integral 1 dx is 5x plus some constant c2, and again here minus 4 times of x to the power of minus 2 plus 1, that is minus 1 divided by minus 1 plus some integral constant c3. On simplifying, you can write x square by 2 plus 5x minus of minus plus 4 upon x plus c1 plus c2 minus c3. So we can consider as a single constant x square upon 2 plus 5x plus 4 upon x plus integral constant c. So we can give the answer x square upon 2 plus 5x plus 4 upon x plus c. Okay. Find the integral x power 3 plus 3x plus 4 upon root x dx. So we can simplify here x to the power of 3 divided by root x plus 3x upon root x plus 4 upon root x dx. So x to the power of 3 divided by x to the power of 1 by 2 plus 3x upon x to the power 1 by 2 plus 4 divided by x to the power of 1 by 2 dx, that is x to the power of 3 minus 1 by 2. Separately I can write dx, and here I can write 3 times x to the power of 1 minus 1 by 2 dx plus 4 times x to the power minus 1 by 2 dx. And now by using the formula, and let me simplify here, x to the power of 3 minus 1 by 2 is 5 by 2 dx, and here integral 3 into x to the power of 1 minus half is half dx, and here 4 times integral x to the power minus 1 by 2 dx. We know integral x to the power of n dx is equal to x power n plus 1 upon n plus 1 plus integral constant c. So we can write here integral, let me write integration of x power 5 by 2 is x to the power of 5 by 2 plus 1 divided by 5 by 2 plus 1 plus some constant c1, and the next one 3 times of x to the power of 1 by 2 plus 1 upon 1 by 2 plus 1 plus some constant say c2, and again plus 4 times of x to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus integral constant c3. So we can simplify and we can write it as x to the power of 5 by 2 plus 1 is 7 by 2 divided by 7 by 2, and here 3 times of x to the power of 1 by 2 plus 1 is 3 by 2 upon 3 by 2 plus 4 times of x to the power of 1 minus half is x power 1 by 2 divided by 1 by 2 plus altogether constants we will take it as single c. So we can also simplify it as 2 x power 7 by 2 divided by 7 plus 2 into 3 6 upon our 3 gets cancelled. So you can write here 2 times x to the power of 3 by 2, and here it is 8 times x to the power of 1 by 2 plus some constant. So this is the final answer. Okay. Find the integral x power 3 minus x square plus x minus 1 upon x minus 1 dx. So we can simplify here. In the numerator from x power 3 and x square, if I take x square common, you can write x minus 1. And from x and minus 1, you can take 1 common and write x minus 1 upon x minus 1 dx. Further, we can just consider this x minus 1 is common here. So I can take out x minus 1 into x square plus 1 upon x minus 1 integral dx. So we may cancel here x minus 1, x minus 1. So integral x square plus 1 of dx, which is equal to integration x to the power of x square dx plus integral 1 dx. By using the formula integral x power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. So here we can write x to the power of 2 plus 1, that is 3 upon 3, plus integration of 1 dx is equal to x plus integral constant. So here this is plus integral constant, and again integration of 1 dx is x plus another constant. So c1 and c2 together I will make it as one constant. So we can write x power 3 upon 3 plus x plus some constant c. This is the answer. Find the integral 1 minus x times root x dx. So you can simplify this integral 1 into root x, that is root x minus x root x dx, integral of root x we can write x to the power 1 by 2 minus x into x to the power of 1 by 2 dx, that is integral x to the power of 1 by 2 dx minus integral x to the power of, here 1 plus 1 by 2 is 3 by 2 dx, and we know that integration x power n dx is equal to x to the power n plus 1 upon n plus 1 plus some constant. So here we can write integral x power 1 by 2 is equal to x to the power of 1 by 2 plus 1 upon 1 by 2 plus 1 plus some constant c1 minus x to the power of 3 upon 2 plus 1 upon 3 upon 2 plus 1 plus some integral constant c2. So which is equal to x to the power of 1 by 2 plus 1 is 3 by 2 upon 3 by 2 minus x to the power of 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 plus c1 minus c2. So which is equal to 2 upon 3 times x power 3 by 2 minus 2 upon 5 x to the power 5 by 2 plus some integral constant c. So we can say that 2 upon 3 x power 3 by 2 minus 2 upon 5 x power 5 by 2 plus c is the answer. Okay. Find the following integrals. Integral root x times 3x square plus 2x plus 3 dx. So we can simplify here. Root x into 3x square plus 2x into root x plus 3 root x of dx. Upon simplifying, 3 into x square into root x we can at x power 1 by 2 plus 2 into x to the power of 1 by 2 plus 3 into x to the power of 1 by 2 the whole dx. And we can separate them. Integral 3 x to the power of 2 plus 1 by 2 is 5 by 2 dx plus integral 2 times x to the power of 1 plus 1 by 2 is 3 by 2 dx, and again integral 3 times x to the power 1 by 2 dx. So 3 times of x to the power 5 by 2 plus 1 upon 5 by 2 plus 1 plus some constant c1, and again here 2 times of x to the power 3 by 2 plus 1 upon 3 by 2 plus 1 plus second constant, and again plus 3 times of x to the power 1 by 2 plus 1 upon 1 by 2 plus 1 plus another constant c3. Since we know that integral x to the power n dx is equal to x power n plus 1 upon n plus 1 plus integral constant c. So here we can write 3 into x to the power 5 by 2 plus 1 is 7 by 2 divided by 7 by 2 plus 2 into x to the power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 plus 3 times of x to the power 1 plus 1 by 2 is 3 by 2 divided by 3 by 2 plus all constants c1, c2, c3 put together as one another constant c. So you can write here c, and on simplification you'll be getting 3 into 2 6 upon 7 x to the power 7 by 2 plus 2 into 2 that is 4 upon 5 times x to the power 5 by 2 plus, and again here 2 times of x to the power 3 by 2 plus constant, and hence 6 upon 7 x power 7 by 2 plus 4 upon 5 x power 5 by 2 plus 2x upon 2x power 3 by 2 plus constant is the answer. Okay. Find the integral 2x minus 3 cos x plus e power x dx. So we can write integration 2x dx minus integral 3 cos x dx plus integral e power x dx. And we know that integration x power n dx is equal to x to the power n plus 1 upon n plus 1 plus integral constant, and integration of cos x dx is equal to sin x plus integral constant, and integration of e power x dx is equal to e power x plus c constant. So let us simplify here. 2 times x to the power 1 plus 1 that is 2 upon 2 plus integral constant say c1 minus 3 times integration of cos x is sin x plus some integral constant C2 plus integration of e power x is e power x plus integral constant C3. So here we can write x square and here minus 3 sin x and plus e power x, and considering this C1 minus C2 and C3 together as one constant as a C plus C. So we can say the answer x square minus 3 sin x plus e power x plus C is the answer. Find the integral 2x square minus 3 sin x plus 5 root x of dx. So we can write it as integral 2x square dx minus integral 3 sin x dx plus integral 5 root x dx. And we know that integration of x power n dx is equal to x power n plus 1 upon n plus 1 plus integral constant c, and integration of root x dx is equal to integration of x to the power of 1 by 2 dx, which is x to the power of 1 by 2 plus 1 upon 1 by 2 plus 1 plus c, that is 2 by 3 x to the power of 3 by 2 plus some constant, and integration of sin x is equal to integration of sin x dx is equal to minus cos x plus some constant. So let us simplify and write here 2 times integration of x square is x to the power of 3 divided by 3 minus 3 times integration of sin x is minus cos x plus some constant c2. Let us take here c1, and again here 5 times integration of root x is 2 by 3 times of x to the power of 3 by 2 plus some constant say c3. So this c1 and c2 and c3 together let us consider to be a single constant c. So we can write 2 upon 3 x to the power 3 minus of minus plus 3 cos x, and here 10 by 3 x to the power 3 by 2 plus constant is the answer. We can use 5 into find the integral secant x of secant x plus tan x dx. So we can write this as integration of secant square x dx plus integration of secant x into tan x dx. And we know that integration of secant square x is equal to tan x plus some constant, and integration of secant x tan x dx is equal to secant x plus integral constant. So we can write here integration of secant square x is tan x plus some constant, and integration of secant x tan x is secant x plus another constant. So let us consider this c1 and c2 as single constant. So we can write tan x plus secant x plus c is the answer. Find the integral secant square x upon cosecant square x dx. So let us simplify this. Secant square x we can add 1 by cos square x divided by cosecant square x we can add 1 by sin square x dx. So we can add sin square x upon cos square x dx, which is integration of tan square x dx. And we know that identity secant square theta minus tan square theta is equal to 1. So tan square theta is equal to integral, we can write secant square x minus 1 of dx. And further simplifying, you can get integration of secant square x dx minus integration of 1 dx. And we know integration of secant square x is tan x plus some constant minus integration of 1 is x plus some constant c2. So we can write tan x minus x plus c1 minus c2. So let us consider c1 minus c2 as some constant, and we can write here tan x minus x plus c is the answer. Find the integral 2 minus 3 sin x upon cos square x dx. So we can simplify and write 2 upon cos square x minus 3 sin x upon cos square x dx, which is equal to 2 times 1 upon cos square is secant square x minus 3 sin x upon cos x, we can write tan x into secant x dx. So next we can write 2 times secant square x dx minus integral 3 times secant x into tan x dx. And we know that integration of secant square is tan x, so we can write 2 tan x plus some constant c1 minus, and we know that integration of secant x tan x is secant x 3 times plus some constant c2, so which is equal to 2 tan x minus 3 secant x, and here plus c1 minus c2 we can write it as one single constant as c. So 2 tan x minus 3 secant x plus c is the answer.